Jupiter has 67 moons. We're about to get number 68, and scientists are deeply uncomfortable. 3I/ATLAS isn't wandering aimlessly through our solar system. New orbital calculations show it's targeting Jupiter's Hill radius with spacecraft-level precision that shouldn't exist in nature. When it disappeared behind the Sun, something happened. The object accelerated in exactly the right way to refine its approach. Natural comets can't do this. So what's really headed for Jupiter? Let's dive right in. When 3I/ATLAS first entered our solar system in 2024, astronomers treated it like any other interstellar visitor. After millions of years drifting through the cosmic void, this chunk of ice and rock had wandered into our neighborhood. The routine was simple: track it, log the data, watch it swing past the Sun, then wave goodbye as it disappeared back into darkness. But then someone actually calculated where this thing was headed. The moment those numbers came back, everything changed. 3I/ATLAS wasn't on some random path through our solar system. It was moving towards something specific, a gravitational sweet spot around Jupiter called the Hill radius. And it was hitting that target with accuracy that shouldn't exist in nature. The calculated intercept point: 53.445 million kilometers from Jupiter's center. The margin of error: just 60,000 kilometers. To understand how impossibly precise that is, imagine standing in New York and throwing a dart that hits a bullseye in Los Angeles. Except you're both moving at different speeds in different directions, and you released that dart 7 years ago. That's what we're witnessing with 3I/ATLAS. Natural comets don't do this. Physics says they can't. So what exactly is this Hill radius that 3I/ATLAS seems to be targeting? Think of it as Jupiter's personal sphere of influence, a massive region of space where Jupiter's gravity overpowers the Sun's pull. It extends roughly 53 million kilometers from the planet's center, creating a zone about the size of Mercury's entire orbit. This isn't just empty space. It's prime real estate in our solar system. Inside this boundary, objects feel Jupiter's gravitational embrace more strongly than the Sun's distant tug. That makes it the perfect parking zone for anything that wants to stay near Jupiter without constantly fighting gravitational forces. Every one of Jupiter's 67 natural moons lives within this zone. When NASA engineers plan missions to Jupiter, they aim their spacecraft toward these stable regions where they can maintain orbits for years without burning excessive fuel. Now here's what makes 3I/ATLAS so profoundly disturbing. Hitting this boundary with pinpoint accuracy requires one of two things: either impossible cosmic luck or deliberate guidance. Sure, plenty of objects pass near planets. Space is crowded with rocks and ice balls on chaotic paths. But there's a universe of difference between passing near something and threading the needle into a specific gravitational zone with surgical precision. That level of accuracy is what mission planners at NASA spend years calculating for actual spacecraft. And 3I/ATLAS is supposedly achieving it naturally. What happened next is where this story shifts from intriguing to genuinely unsettling. In early 2025, 3I/ATLAS reached perihelion, its closest approach to the Sun. For any normal comet, this is when things get wild. Solar heat causes the ice to violently sublimate, creating explosive jets of gas that shove the comet around like a pinball. The trajectory should have become messier, increasingly chaotic. Instead, something impossible happened. The path toward Jupiter's Hill radius became tighter, more refined, more exact, as if someone had made a course correction. But here's the detail that haunts astronomers. The refinement occurred during solar conjunction. a 40 to 60-hour window when the sun positioned itself directly between Earth and 3I/ATLAS. During those crucial hours, our telescopes went blind. Solar glare overwhelmed our instruments. We couldn't see what was happening. When 3I/ATLAS emerged from behind the sun's glare, something had fundamentally changed. The object had experienced what scientists call a non-gravitational acceleration event. In plain English, something pushed it. The velocity increased, the direction shifted, and both changes occurred in precisely the manner needed to optimize the approach to Jupiter's Hill radius. The conventional explanation sounds reasonable at first: outgassing from sublimating ice-created thrust that nudged the object onto a slightly different path. We've seen this happen with dozens of comets before, except the details don't quite fit. Natural outgassing is inherently chaotic. When ice sublimates on an irregularly shaped, rotating comet, it creates jets shooting off in random directions. The result is usually tumbling, erratic motion. Yet 3I/ATLAS displays an unusually symmetrical coma, the cloud of gas surrounding it. There are no detectable jets, no rotating outgassing sources, none of the typical signs of asymmetric sublimation that would explain the acceleration. It looks remarkably stable, almost artificially so. More troubling is the direction of the push. When you map the velocity change, it points in the precise direction needed to tighten the approach to Jupiter's Hill radius. Not approximately. Exactly. This was clean. This was targeted. This was the kind of burn you'd see from a spacecraft making a deliberate course correction. And it happened during the one window when we couldn't watch. There's another piece of this puzzle that reveals something profound about 3I/ATLAS's mission, whatever that mission might be. On its journey to Jupiter, this object passed relatively close to Earth. Close enough that any probe equipped with even basic sensors could have gathered enormous amounts of data about our planet, our atmospheric composition, our electromagnetic emissions, the thermal signatures of a technological civilization. This was a golden opportunity for reconnaissance. 3I/ATLAS did absolutely nothing. No course adjustments, no orientation changes that might indicate sensors swiveling toward Earth. No thermal variations suggesting equipment activating. Nothing. It flew past Earth like we weren't even there, like a driver on the highway passing an exit without slowing down, without even glancing at the sign. That indifference cuts deeper than hostility ever could. It suggests something deeply unsettling. We're not the destination. We're just scenery along the route to somewhere more important. If 3I/ATLAS is artificial, if it's executing a planned mission, then Earth was never part of the equation. Whatever happens at Jupiter, that's the real objective. Understanding why Jupiter might be the actual target requires thinking like a strategist. If you're sending probes to other star systems, Jupiter is exactly where you'd want to set up permanent infrastructure. Not Earth, not Mars, Jupiter. The reasons are brutally practical. Jupiter's magnetosphere is the largest and most powerful structure in our solar system. For any technology capable of harvesting electromagnetic energy, Jupiter is a cosmic power plant offering free, endless energy that could run autonomous systems for centuries. The Hill radius provides orbital stability that's impossible to find elsewhere. Place a probe in this zone, and it stays there for decades with minimal adjustments. No fuel burned, no complex maneuvers needed, and the strategic view is unmatched. From Jupiter's Hill radius, you can see the entire inner solar system spread out like a map. Earth, Mars, Venus, Mercury, all visible, all trackable. Radio emissions from Earth would wash over your position constantly. Meanwhile, you're positioned in a radiation-soaked environment where biological organisms can't survive. Primitive civilizations like ours literally can't reach you safely. It's the perfect observation post, close enough to see everything, far enough to remain undisturbed. There's a concept called Sentinel theory that sounds like science fiction but is grounded in reasonable physics. And 3I/ATLAS might be demonstrating exactly how it works. Advanced civilizations don't send themselves to other star systems. They send machines, autonomous probes that can survive the journey, arrive at the destination, and then multiply, disperse, build networks. A carrier craft arrives carrying dozens or hundreds of smaller units designed for long-term monitoring. It approaches a gravitationally stable region like Jupiter's Hill radius and performs a dispersion event. The smaller probes detach, break into different orbits, and position themselves at strategic points throughout the system. Some head for Lagrange points, others settle around major moons. The brilliance is efficiency. One carrier deploys a complete observation network. Over millions of years, this strategy could fill the galaxy with Sentinel networks, each quietly monitoring its assigned star system. So, what would deployment look like from our perspective? As 3I/ATLAS crosses into Jupiter's gravitational domain, our instruments might detect what appears to be a fragmentation event, the object coming apart into multiple pieces. This happens with natural comets constantly, so initially nobody would react. Ice and rock separating due to tidal forces, perfectly normal. But then the fragments don't behave like debris. They decelerate in coordinated ways. They move toward different destinations with purpose, some heading for Lagrange point L1, others toward L2, a few diving deeper toward Jupiter's moons. The individual objects would be small, just a few meters across, with surfaces designed to absorb rather than reflect light. Within weeks, they'd scatter across the Hill radius region, each settling into a stable position. From Earth, we'd observe a comet that fragmented near Jupiter. Nothing unusual. What we wouldn't see is the network being established. Dozens of autonomous probes taking up residence in our solar system's gravitational architecture. By the time anyone realized something strange had occurred, the deployment would be complete. Behind official statements, 3I/ATLAS has torn the astronomical community into opposing camps. Researchers looking at identical data are reaching completely opposite conclusions. Those arguing against natural explanations point to mounting problems. The trajectory refinement requires incredibly specific conditions. Ice concentrated exactly right, rotation aligned perfectly, timing coinciding precisely. String enough coincidences together and you stop calling it luck. The coma symmetry is unusual. Most active comets display irregular, patchy comas with visible jets. 3I/ATLAS shows an eerily smooth, uniform coma, and it's holding together better than expected for an object supposedly undergoing violent outgassing, strong enough to alter its trajectory. But arguments supporting natural explanations carry weight too. Comets genuinely are weird. Every close-up study surprises us. The math of orbital calculations is tricky, with error bars that can hide uncertainty. Yet here's what keeps even skeptics awake. With each new observation, the trajectory gets refined, and every refinement confirms the approach to Jupiter's Hill radius. The pattern strengthens instead of dissolving. At some point, coincidence stops being satisfying. 3I/ATLAS is the third confirmed interstellar object we've detected. When you line them up, something uncomfortable emerges. Oumuamua in 2017, elongated, tumbling, accelerating with no visible outgassing. Avi Loeb proposed artificial origin. The community pushed back, but natural explanations had problems. 2I/Borisov in 2019 looked reassuringly normal. Everyone relaxed, proof that most interstellar visitors are just cosmic debris. Then 3I/ATLAS arrives with a coma and activity, but trajectory too precise, timing too convenient, target too specific. It's as if someone learned from Oumuamua's mistakes, designed the next probe to look just comet-like enough to maintain plausible deniability while accomplishing its mission. While astronomers debate, artificial intelligence is revolutionizing our ability to observe the cosmos. AI-powered telescopes now detect thousands of microflares every night, events we previously missed entirely. Transient objects appearing for single frames, then vanishing. Fast movers at puzzling velocities. The Vera Rubin Observatory will soon photograph the entire visible sky every few nights, generating more data than any human team could analyze. We're suddenly seeing things we couldn't before, and what we're seeing is stranger than expected. Maybe we're discovering new phenomena, or maybe we're finally noticing things that have been there all along. Invisible until we built machines sophisticated enough to spot them. Over the coming months, 3I/ATLAS will reach Jupiter's Hill radius. We'll be watching with telescope arrays and AI systems that can detect what we missed before. If this is a natural comet, it'll pass through Jupiter's gravitational zone and continue its journey. The debate ends, and we move on. But if that spacecraft-level precision proves real, everything changes. The most profound possibility isn't hostile invasion, it's strategic indifference. Something crossed interstellar space, ignored Earth completely, and headed straight for Jupiter because that's where the actual value is. We're not the target. We're just locals watching infrastructure get built next door. Here's the reality. We're living through a moment that will define how future generations understand our place in the universe. Whether 3I/ATLAS is an incredibly lucky comet or evidence of something far more significant, we'll know soon. What do you think is really approaching Jupiter? Natural phenomenon or deliberate mission? Share your take in the comments below. If you want to follow every development as 3I/ATLAS reaches its destination, subscribe to Galactic Breaking News and hit that notification bell. We'll be covering every observation and data point as this unfolds. And if this video opened your eyes to how strange our solar system is becoming, hit the like button and share it with someone who needs to see this. The universe just got a lot more interesting. We'll be here tracking what comes next. Thanks for watching Galactic Breaking News.